Hello students, let us start with a new chapter, waveform generators. This chapter has 14 marks in your syllabus for your examination. Here in this chapter we will start with the oscillators and we will study what is the need of the oscillator, what are conditions for oscillation and classification of oscillator and different types of oscillators. So let us see what is first of all the oscillator. An oscillator is a device which produces an output signal without any input signal of desired frequency. Oscillators operate on DC power supply and produces an alternating output voltage. Oscillator operates on the principle of positive feedback. Now in the last chapter we had seen amplifiers. In amplifiers we give negative feedback, but in oscillators we give positive feedback. So please remember this, that for oscillators you should always give positive feedback. Now what is this oscillator? Basically it is an electronic device or electronic circuit that produces a periodic oscillating electronic signal. It can be often sine wave or square wave. So when you give a oscillation, whenever you produce an oscillating circuit, it will give you sine wave or square wave as your output. So this oscillator basically convert direct DC from power supply to AC signal. So no AC signal is required at the input of an oscillator. So oscillator does not require a separate input. It will give you output. They are basically signal generators which you can use in your labs. The output voltage and the frequency of an oscillator can be variable. So now understand that oscillator operates on the DC power supply, and more importantly it produces alternating output voltage without any alternating input voltage. Means without any input, alternating input, it will give you alternating output voltage. And remember always that positive feedback, that they operate on the principle of positive feedback. So we will study what is positive feedback. So positive feedback, what is positive feedback? Positive feedback is feedback signal which is applied in phase with the input voltage. So for the amplifier we used to give negative feedback. For the oscillators we give positive feedback. Now what is the need of oscillators? For many electronic circuits we need to use alternating voltage source which can produce periodic waveform. Now what are periodic waveform? Sine wave or square wave of specific frequency on its own which is completely different than the mains frequency. What is the mains frequency? 50 Hz. Now this is the diagram of an oscillator. We can see that there are amplifier and a feedback network. So basically a oscillator consists of an amplifier and a phase shifting network. Why phase shifting network? See, this is your amplifier network and this is your feedback network. This also gives you 180 degree phase shift. Okay. So an oscillator consists of basically an amplifier and a phase shifting network. The amplifier receives the output of the phase shifting network. The amplifier then amplifies it, and phase shift is through 180 degree and applies to the input and the phase shifting network. The phase shifting network shifts the amplifier output through the another 180 degree and attenuates it before applying to the amplifier in the input. So there is total phase shift of 360 degree. The feedback becomes positive feedback which gives rise to oscillation. So for this you require Parkhouson's criteria satisfied. We will see what is Parkhouson's criteria in the next slide. So basically here you will get no external AC input voltage and you will be given output in the alternating voltage. So basically an oscillator is an amplifier with positive feedback. See, this is your Vs. Here you have 180 degree phase shift. Here you have 180 degree phase shift. So total 360. This is your output voltage. This is your feedback network having parameter beta. So feedback factor is beta into V0. This is your feedback signal. So Vf is equal to beta V0. This is your AV. This is your input Vi. Vi is always Vs plus Vf. Vs plus Vf. What was Vf? beta V0. Okay. See, as I said, we know that Vi is equal to Vs plus Vf. So Vs will be what? Vi minus Vf. But Vf is equal to beta V0. Therefore, Vs is equal to Vi minus beta V0. Now, we all know what is gain. Gain is always A is always V0 upon Vi, right? Output upon input. So here AF is equal to with feedback, that is why it is gain with feedback, that is why it is known as AF. So gain of amplifier with feedback is given as AF is equal to V0 upon Vs, and we already know what is Vs. Vs is Vi minus beta V0. Therefore we are getting V0 upon Vi minus beta V0. So now let us divide this by Vi. So we will divide numerator and denominator by Vi. So you can see, this is Vi divided everywhere in the numerator as well as denominator, right? So this Vi gets cancelled. So we get 1 minus beta V0 upon Vi. I already told you what is V0 upon Vi. It is equal to A. So let us replace this by A. So A is what your gain. So A is open loop gain of an amplifier. So here we are replacing it by A. Clear? So let us see what is the need of positive feedback. From the equation of gain with feedback, that is AF is equal to A upon 1 minus A beta. Here A 1 minus A beta is less than 1 since AF is positive. Therefore AF is greater than A. Thus positive feedback increases the gain of an amplifier. With increase in the value of beta, keeping A constant, then AF will increase. At a particular value of beta, AF becomes infinity. This means that without input signal Vs, the amplifier will keep producing output voltage with the help of a feedback signal. So without giving input, it will keep on giving you the output. Thus, amplifiers start acting as an oscillator with the use of positive feedback. Hence, positive feedback is required for an oscillator. So today what we have seen, what are oscillators, what is the need of oscillator, how the equation is derived, what is the block diagram of oscillator, and why the need of positive feedback. In the next video we will see what is Barkhausen's criteria and what is the classification of oscillators. Thank you.